You take your vehicle to the local shop because it has been idling a little rough at stoplights and getting absolutely terrible fuel economy. The mechanic tells you it needs a tune-up, quotes you around $400, and you hand over your credit card thinking your engine is getting the ultimate royal treatment. But the harsh reality of the automotive repair industry is that the technician probably just grabbed whatever bulk spark plugs the shop gets the best wholesale rate on, slapped them into the cylinder head without checking the gap, and completely ignored the health of your ignition coils to beat the flat rate clock. Most drivers have absolutely no idea that the real secret to a perfectly smooth engine, maximum miles per gallon, and restoring that crisp off the showroom floor throttle response is not just randomly swapping parts. It requires a very specific, almost surgical diagnostic process that most commercial shops simply do not have the time to do. Today we are going to walk through exactly how your ignition system actually works under the hood, why putting the most expensive parts in your engine might actually destroy it, and how you can perform a master-level spark plug service right in your own driveway. Before you even grab a socket wrench, your car is usually screaming at you that the ignition system is getting tired and failing. You might notice a slight, annoying hesitation when you press the gas pedal to merge onto the highway. Or maybe you are sitting at a drive-thru and you feel a random, heavy vibration pulsing through the steering wheel. That feeling is an intermittent engine misfire. A misfire happens when the spark plug fails to ignite the highly compressed air and fuel mixture inside the combustion chamber. When that spark fails, raw, liquid gasoline gets pumped straight out of your exhaust valves and travels directly into your catalytic converter. A catalytic converter is a vital emissions component that operates at incredibly high temperatures. When that raw, unburnt fuel hits the glowing hot ceramic honeycomb structure inside the converter, it acts exactly like a blowtorch. It superheats and can literally melt the precious platinum and palladium metals inside, destroying a $2,000 exhaust component in a matter of weeks. Furthermore, your oxygen sensors read that unburnt oxygen passing through the exhaust, tricking the engine computer into thinking the motor is running too lean. The computer responds by dumping even more fuel into the cylinders, which completely tanks your fuel economy and washes the protective oil film right off your cylinder walls. Ignoring a slight engine shudder or a flashing check engine light is one of the most financially devastating mistakes you can make as a car owner. The automotive manufacturers love to print in their owner manuals that their modern vehicles can go 100,000 miles before ever needing a tune-up. They do this intentionally to make the estimated cost of ownership look fantastic on paper for fleet buyers and lease agreements. But that long-life vision is based on pristine laboratory conditions, running the engine at a steady highway speed of 65 miles per hour for hours on end. Your actual daily commute is a brutal environment. It involves freezing cold starts, sitting in heavy stop-and-go gridlock, and making short 5-mile trips to the grocery store where the engine block never even reaches its proper operating temperature. In the real world, standard copper spark plugs are completely worn out and degrading your performance by 25,000 to 30,000 miles. Single platinum plugs, which are common in many base model sedans, will give you about 45,000 to 60,000 miles of healthy life. Premium, double platinum, or high-end iridium plugs should be strictly retired around the 60,000 to 80,000 mile mark. If you do a lot of heavy towing, live in a mountainous region, or have a heavy foot on the accelerator, you need to cut those lifespan intervals down by at least 20% to keep your combustion cycle running clean and efficient. Pushing your spark plugs past their intended lifespan does not save you money. It just slowly kills your catalytic converter and strains your entire electrical system. When you walk into an auto parts store, the person behind the counter is almost always going to try and upsell you to the most expensive iridium spark plugs sitting on the top shelf. The parts are arranged in a strict hierarchy of price, from standard copper at the bottom to platinum in the middle, and exotic metals like ruthenium and iridium at the very top. But spending more money does not mean you are getting a better part for your specific motor. Copper actually has the highest thermal conductivity of all three materials, meaning it pulls destructive heat away from the combustion chamber incredibly fast. If you are driving an older, high-performance forced induction car, like a turbocharged 1990s sports car running high boost pressure, copper plugs often resist pre-ignition, an engine knock much better than a modern iridium plug ever could. Platinum became the standard throughout the late 90s and early 2000s for standard port fuel injected engines, providing a really solid balance of longevity and consistent performance. Iridium, on the other hand, is absolutely required for modern, direct injected, ultra-lean burn engines that need a microscopic, highly focused spark core to ignite a very difficult and pressurized air-to-fuel mixture. The golden rule of automotive maintenance is to always stick exactly to the original equipment manufacturer specification. If the engineers who built your engine designed the ignition coils and combustion chamber specifically for a copper plug, you must use copper. Slapping an expensive iridium plug into an ignition system tuned for copper will not give you 10 extra horsepower. It will likely cause hard starting issues, erratic idling, and prematurely fry your expensive ignition coils. Before we get into the exact step-by-step teardown process of how to read your old engine parts like a seasoned mechanic and uncover hidden mechanical failures, if you want to stop getting ripped off at the repair shop and learn how your vehicle actually works, take a second to hit that subscribe button so we can keep bringing you these deep technical dives into your garage. The actual physical process of changing spark plugs requires absolute cleanliness, which is a step that a rushed flat rate mechanic rarely cares about. Before you even put a socket on the old spark plugs, you have to carefully look down into the deep spark plug tubes bolted to the top of your engine. Over the years, sand, grit, dead leaves, and oily road dirt accumulate deep down in those wells. If you unscrew the old spark plug without cleaning that area first, all of that highly abrasive debris is going to fall directly through the open spark plug hole and straight into your engine cylinders. The moment you turn the key and start the car, that dirt acts like liquid sandpaper, aggressively scoring the aluminum cylinder walls and destroying your piston rings. You absolutely must take an air compressor, or even just a can of compressed air from an office supply store, and completely blow out the spark plug wells before you loosen anything. When you are unclipping the electrical connectors from the ignition coils to get them out of the way, you also have to be incredibly gentle. The plastic locking tabs on those wiring harnesses have been baking in engine heat for years and become as brittle as dry pasta. If you force them, they will snap right off, leaving you with a loose connection that will vibrate off while you are driving down the road. Once you safely extract the old spark plugs, do not just throw them in the trash can. Those old plugs are essentially little mechanical data loggers that tell you exactly what is happening inside the dark, violent heart of your engine. Line them up on your workbench in order from cylinder 1 to your last cylinder, and closely inspect the firing tips. If the white ceramic insulator is completely coated in a thick, fluffy black soot, your engine is running way too rich, meaning your fuel injectors or computer are dumping far too much gasoline into the mix. If the tip looks blistered, melted, and chalky white, the engine is running dangerously lean and hot, which is a condition that can eventually melt a hole right through the top of an aluminum piston. If you pull the plug out and the threaded metal body is completely dripping in wet, shiny motor oil, you do not actually have a spark plug problem at all. You have a failing rubber valve cover gasket or blown spark plug tube seals that are allowing engine oil to leak down from the top of the cylinder head and drown your ignition system. Reading the story your old spark plugs tell you is the single most accurate diagnostic tool you have at your disposal. While the spark plugs are sitting on the bench, you have to meticulously inspect your ignition coils. In modern coil on-plug ignition systems, a dedicated coil sits directly on top of each individual spark plug, acting as a massive electrical step-up transformer. It takes the basic 12 volts from your car battery and violently amplifies it to tens of thousands of volts to jump the air gap inside the pressurized cylinder. Because these plastic coils sit bolted directly to the hot cylinder head, they endure brutal thermal expansion and contraction cycles every single day. Over the years, the plastic housing and the long rubber boots, stretching down to the plug, become brittle and develop microscopic fractures. High voltage electricity is lazy. It will always take the path of absolute least resistance. Instead of traveling all the way down the internal spring to the spark plug, that intense electrical voltage will arc straight through those microscopic cracks in the rubber and ground out directly against the metal engine block. You have to look incredibly closely at the rubber coil boots under a bright flashlight for something called carbon tracking. Carbon tracking looks exactly like a faint, jagged black line drawn with a pencil running down the side of the rubber boot. That black line is literally a physical scorch mark left behind by escaping high-voltage electricity. If you see any signs of carbon tracking, or if the rubber boot is torn or heavily swollen from oil exposure, that ignition coil is fundamentally dead. It must be thrown away and replaced the exact same day you install the new spark plug. If you reuse a compromised coil, your brand new spark plug will not receive enough electrical energy to create a proper spark core, and your engine misfire will remain completely unfixed. We're about to cover the single biggest lie the automotive parts industry prints right on the side of the box. The one critical installation step that dictates whether your engine runs flawlessly or shakes itself to pieces under load. But right before we get to the final installation secrets, make sure you are subscribed to the channel to keep building your automotive knowledge and saving your hard-earned money. If you look at the cardboard box your brand new spark plugs come in, you will almost always see the words pre-gapped printed right on the side in bold letters. Do not ever trust that marketing claim. Spark plug manufacturers produce these items by the tens of millions. They are tossed into giant shipping crates, bounced around in the back of delivery trucks over rough highways, and dropped on the floor by warehouse workers. All it takes is one small impact against a hard surface to accidentally bend the metal and close the gap on a spark plug. The gap is the precise, microscopic distance between the center electrode and the metal ground strap hovering above it, and it entirely dictates the size and health of the electrical arc. If the gap is too narrow, the spark core remains too small to ignite the fuel quickly and efficiently, resulting in sluggish acceleration and wasted gas. If the gap is too wide, the ignition coil might not have enough raw voltage to push the electricity across that massive divide when the engine is under heavy load, causing severe high RPM misfires that will drive you crazy trying to diagnose. You have to look up the exact gap specification for your specific motor, which is usually printed right on the white emission sticker stuck to the underside of your hood, and use a wire-style feeler gauge to measure every single new plug before it goes into the engine. Avoid the cheap coin-style gauges, as they can easily damage the delicate tips. If the plug needs adjustment, you only ever use a specialized tool to bend the outer ground strap. You must never pry against the fragile center electrode, especially on an expensive iridium plug, because you will snap the microscopic rare earth metal tip right off and ruin the brand new part instantly. When it comes time to finally install the new plugs, you have to treat the threads with absolute respect. Most modern cylinder heads are cast from very soft aluminum, while the body of the spark plug is machined from hard steel. If you accidentally cross-thread the plug and try to force it in, or if you over-tighten it using a massive half-inch drive ratchet, you will effortlessly strip the aluminum threads right out of the cylinder head. Doing that instantly turns a $50 afternoon maintenance job into a $2,000 machine shop nightmare where the engine head has to be removed and repaired. You also need to pay attention to the finish on the new plugs to settle the endless debate about using anti-seize paint. Most premium NGK and Denso spark plugs come from the factory with a specialized trivalent zinc or nickel coating on the threads. This silver coating acts as a chemical release agent, meaning those specific plugs are designed by the engineers to be installed completely dry. If you slather heavy copper anti-seize paste all over coated threads, the fluid lubrication throws off the friction coefficient. This causes you to accidentally over-tighten the spark plug by up to 20% past its breaking point, severely stretching the metal housing and altering the internal heat transfer property. If you are using old-school, uncoated black steel spark plugs, then applying a tiny, microscopic dab of anti-seize is acceptable. You should always thread the spark plug into the hole entirely by hand, using just an extension bar for the first few turns to ensure it is threading perfectly smooth. Once it is seated, use a properly calibrated torque wrench to lock it down to the exact foot-pounds specified by the manufacturer. Before you push the ignition coils back down onto the plugs, put a tiny dab of dielectric silicone grease right inside the opening of the rubber boot. This seals out moisture, prevents electrical arcing, and guarantees that the boot will pop off easily the next time you service the vehicle. Reconnect your wiring harnesses, ensure every plastic clip clicks securely into place, and take the car for a full drive cycle. A properly executed spark plug service, utilizing all of these professional techniques, will instantly smooth out a rough idle, bring back that snappy, aggressive throttle response you have been missing, and keep your engine running at peak efficiency for years to come. Taking care of your engine's ignition system is not about blindly throwing expensive aftermarket parts at the motor and hoping for the best. It is about paying attention to the fine mechanical details, reading the physical signs your car is giving you, and executing the repair with absolute precision. Have you been fighting a mysterious check engine light, dealing with a flashing P300 random misfire code, or noticing your gas mileage falling off a cliff recently? Drop your car's year, make, model, and the exact symptoms you are experiencing down in the comments below. I read through as many as I can to help you guys track down these annoying drivability issues and get your rides running perfectly again. Make sure you hit that subscribe button one last time. Leave a thumbs up if this technical breakdown saved you a frustrating trip to the mechanic, and I will see you under the hood in the next video.